Introduction to pressure. Let's start with the basic definition. Pressure is the force acting per unit area of a surface. We write it as backhand index pointing right pressure equals force/area, or P equals F/A. Its SI unit is Nm2, also called Pascal/Pa. So, if you apply the same force over a smaller area, the pressure increases. Liquid pressure. Now, what is liquid pressure? Liquid pressure is the pressure exerted by a liquid on the walls of its container. Let's derive the formula. We begin with backhand index pointing right P equals F/A. Now, F equals mg. And since density, d, equals mass/volume, and volume equals L times B times H, we substitute everything and simplify. Eventually, we get backhand index pointing right P equals H times D times G. This means more depth equals more pressure. Higher density equals more pressure. More gravity equals more pressure. So liquid pressure depends on three things: depth, density, and gravity. Pascal's law. Let's move on to Pascal's law, a very important principle. It states, backhand index pointing right, the pressure applied to an enclosed liquid is transmitted equally in all directions. This law is the foundation of hydraulic machines, like hydraulic lifts, brakes, and presses. In a hydraulic system, we use this formula. Backhand index pointing right F1/A1 equals F2/A2. Here, a small force applied on a small piston, A1, generates a large force on a bigger piston, A2. That's why hydraulic machines are called force multipliers. But remember, this only works because the liquid is incompressible and transmits pressure equally in all directions. Upthrust. Now, let's talk about upthrust. When you immerse a body in a liquid, you feel an upward push. This is upthrust. It is the force exerted upward by the liquid. Backhand index pointing right upthrust equals loss in weight of the object. And what does upthrust depend on? Density of liquid. Volume of object immersed. Gravity. That's why it's easier to lift a bucket inside a well than in air, because the water gives an extra upward push. Archimedes' principle. Archimedes said, backhand index pointing right, when a body is fully or partially immersed in a liquid, it experiences an upthrust equal to the weight of the liquid displaced. In short, backhand index pointing right upthrust equals weight of liquid displaced. Let's remember, this explains both floating and sinking. Law of flotation. This law says, backhand index pointing right, a floating body displaces liquid equal to its own weight. So, if the weight of displaced liquid equals weight of the object floats. Mercury barometer and atmospheric pressure. Let's understand how we measure atmospheric pressure. We use a mercury barometer. It has a 1-meter-long glass tube filled with mercury and inverted in a mercury-filled trough. Due to atmospheric pressure, mercury stays up in the tube. Standard atmospheric pressure at sea level equals 760 of mercury. The vacuum formed at the top of the tube is called Torricellian vacuum. When you go to higher altitude, atmospheric pressure drops and the mercury level falls. We can use water instead of mercury, but the tube must be 10 meters tall. Applications of atmospheric pressure. Let's talk about some common devices. A syringe, when you pull the plunger, a vacuum is formed. Atmosphere pushes the liquid in. B, air pump, pulling in air, then compressing it to fill tires. C, water pump, works on atmospheric pressure, can lift water only up to 10 meters. Now some conceptual questions. Why does a ship float on seawater, but not on river water as easily? Backhand index pointing right because seawater is denser, so it gives more upthrust. Why does a balloon rise in water? Backhand index pointing right due to upthrust. Why do we float better in salt water? Backhand index pointing right again. Higher density equals more upthrust. Why can't gas be used in hydraulic machines? Backhand index pointing right, because gas is compressible and doesn't transmit pressure equally.